Okay, then let us continue. So polar plot. So it is a graphical representation of the sinusoidal transfer function. So if we have sinusoidal transfer function g of j omega, so simply you determine the magnitude of g of j omega and determine the phase angle of g of j omega, and for the magnitude as well as for the phase angle for different values of omega. Okay, determine different values of the magnitude and different values of the phase angle. Okay, so for different values of the omega you can get different values of the magnitude of sinusoidal transfer function and different values of the phase angles of sinusoidal transfer function. So if we have different values of the magnitude as well as different values of the phase angles, we can plot the graph, magnitude versus phase angle graph. So if we are able to plot the magnitude versus phase angle graph for the sinusoidal transfer function, that graph you can call it as polar plot. So what is polar plot? Polar plot, it is the plot of sinusoidal transfer function g of j omega for the magnitude of g of j omega versus angle of phase angle of g of j omega as omega varies from 0 to infinity. Okay, so simply we can say polar plot is the locus of vectors of vector g of j omega at an angle g of j omega as omega varies from 0 to infinity. So this polar plot, it is usually plotted on polar graph sheet. So what is polar graph sheet? This is the polar graph sheet. So this polar graph sheet will be consisting of concentric circles. Sorry. This polar graph sheet will be consisting of concentric circles. You can see here circles. So you can see circles here. So concentric, my pen in this PPT, the pen that I am using is not operating properly. It has concentric, see, this is what is happening. I am unable to use it properly. So it has concentric circles. You can see a circle here. I will use the arrow mark instead of pen. Okay, I have a laser pointer here. So this is a circle. So you can see a number of circles are there, and all the circles are cut by radial lines. So these are all the radial lines. Okay, so these are all the radial lines. So these are all the radial lines. So this graph is known as polar graph. So the what to say? Yeah. So here the circles represent the magnitude. Okay, circles represent the magnitude, whereas sorry, I wanted the pen. So okay, circle represents what? It represents the magnitude, whereas these radial lines, they represent the phase angles. Okay, so each point on the polar graph, where is it? Yeah. Each point on the polar graph has a magnitude as well as a phase angle. Okay, so this is it. Now if you see here, um, this is a four quadrant diagram. So in this four quadrant diagram, there is only one circle is there. One concentric circle is shown here. And what is this? This is the origin. So what is this? This is our origin. So uh, uh, the from the origin, the radius of this circle, I can say from the origin, the radius of the circle will give us the magnitude and angle made by this vector. Okay, this vector which is starting from the origin ending at the circumference of this circle, I can say. So the angle made by this vector with respect to the reference axis, whichever axis is our reference axis, the angle made by the vector with respect to the reference axis is the phase angle. Okay, so the phase angle is the angle made by the this vector with respect to the reference axis, and the length of the vector, that is the radius of the circle, is nothing but the magnitude. Now at the reference angle axis, the angle is 0. If I am moving in anticlockwise direction, if I am moving in anticlockwise direction, then the angles are usually considered as positive angles. Means if you see here it is 0 degrees, next 90 degree plus 90, next plus 180, next plus 270, and so on. Okay, and so on means at last we will end at 0 degree only. The 360 degrees is nothing but 0. Now if you move in clockwise direction, so this is 0 degree in clockwise direction, minus 90, minus 180, minus 270, and so on. Okay, so just remember that. So if we move in anti-clockwise direction, angle should be considered positive. If we move in clockwise direction, angle should be considered as negative. Okay, angle should be considered negative in clockwise. Okay, in anti-clockwise, angle should be considered positive. Okay, and length of the radius of the circle or the length of the vector from the origin is nothing but the magnitude, and the angle made by the vector with respect to the reference is nothing but the phase angle. Okay, now usually we will use normal graph sheet to draw the polar plot. So in order to draw the polar plot on the normal graph sheet, okay, what we have to do is we have to represent the sinusoidal transfer function in rectangular coordinates. Okay, so just now we have discussed that we can represent g of j omega in terms of its magnitude and phase angle. So but in order to plot the graph, instead of plotting it on the polar graph sheet, you can plot the polar plot on the normal graph sheet. So if I want to plot the polar plot on the normal graph sheet, then what I have to do is I must have the rectangular coordinates forms of the g of j omega. Means I must convert the polar form into rectangular form. So g of j omega, if it is converted in rectangular form, g r j omega is the real part, g I j omega is the imaginary part. G r j omega is the real part and g I j omega is the imaginary part. If you have any disturbance, please mention in the chat box. If you have any disturbance, please mention in the chat box. Okay, so I will continue. So I'm again and again, once in a while, checking whether slide is wearing or not. If the screen has freezed and all those things I have been checking again and again, so that I want this class to run smoothly. That's my main aim. So what is gr of j omega? It is the real part of g of j omega, and gi of j omega is the imaginary part of the g of j omega. Okay, so we can plot the polar plot on the ordinary graph that we usually use. Okay, we can plot the polar plot on the ordinary graph sheet. In between what now? In between the real part of g of j omega and imaginary part of g of j omega, as omega varies from 0 to infinity. Okay, as omega varies from 0 to infinity. Okay, now let us see from where this polar plot, it has to start from some point. Okay, and it has to end at some point. So the polar plots, let us see the starting points of the polar plots. So start of the polar plots will be always from the end of the each axis. Okay, from the end of each axis, usually it will be from some typical cases are there. In that case, typical cases will have their own conditions, but in general they usually start from the end of the axis. And from which axis they will start? Okay, from 0 degree axis or plus 90 or minus 90 or plus 180 or minus 180 or plus 270 or minus 270. It will depend on type of the system. Depending on the type of the system, okay, depending on the type of the system, the polar plot direction means polar plot from which axis the polar plot will start, or from which coordinate we can say, from which coordinate polar plot will start will depend. Okay, so you can see here from the reference axis, from the reference axis the polar plot will start if the type of the system is 0, type 0. Okay, so you know how to determine the type 0. Okay, how to know whether the given system is type 0 or type 1 or type 2 or type 3. So if it is a type 0 system, the polar plot will start from the 0 degree axis or reference axis. So if it is type 1 system, it will start from the, we are moving in clockwise, isn't it? We are moving in clockwise now. It will start from the minus 90-degree axis. It will start from minus 90-degree axis. So type 1 system. If it is type 2 system, since we are moving clockwise, we must consider angles in negative angles. So minus 180 degrees. Okay, this is degree. Okay, minus 180 degree. And if it is type 3 system, then the plot will start from, the plot will start from minus 270-degree axis, from the end of the minus 270-degree axis. Okay, from the end of 270-degree axis. Okay, so here this is 0 degree reference axis or 0 degree axis. Okay, so depending on type, okay, from where, from which axis or from which coordinate the polar plot will start will depend. So type 0, for type 0 system, it will start from the first coordinate or first reference axis. From minus 90-degree axis, it will, polar plot will start if it is type 1 system. From minus 180-degree axis, polar plot will start if it is type 2 system. From minus 270-degree, polar plot will start if it is type 3 system. So here, why I am considering this as minus angles? Why? Because I am moving in clockwise direction. Now, where will these polar plots will end? Okay, the polar, all the polar plots will usually end at the origin, except some typical cases. But okay, so if you see here, um, if the order of the system, okay, if we know the order of the system, order will decide the end of the polar plot, type will decide the start of the polar plot. So if it is an order first order system, if it is first order system, it will end in between the reference axis and minus 90-degree axis, or in the fourth quadrant, I can say. Okay, it end, the polar plot will end in the fourth quadrant. Okay, isn't it? This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So polar plot will end in the fourth quadrant. Okay, it will end in the fourth quadrant if it is if the order of the given system is first order system. Now if the order of the system is second order, then it will end in the at the origin of the third quadrant. And if the order of the system is third order, then it will end in the second quadrant of at the origin of the second quadrant. And if the order of the system is fourth order, then the polar plot will end at the origin of the first quadrant. Okay, so order will always decide the end of the polar plot, type will decide the origin of the polar plot. Till now, is it okay? Till now, is it okay? Can anyone mention in the chat box? Till now, is it okay? Okay then. I'll proceed. Please wear your earphones if my voice is low. Because in my mobile I am able to hear my voice. I'm using my laptop to take the class. Okay, then let us proceed further. Now, if I am able to plot the polar plot, okay, and if I want to make any changes in the shape of the polar plot, okay, if I have a polar plot and if I want to change the shape of the polar plot, okay, so for that what I can do is simply I can add a pole, I can add a pole or zero. Okay, I can add a pole or 0 to the polar plot. I can add a pole or 0 to the polar plot. So if I'm able to add a pole to the given system, okay, if I'm able to add the, sorry, if I'm able to add a pole to the given system, then what will happen is, if I'm adding a pole, one second, yeah, this is it. I'm unable to find my cursor. If pole is added to the system, then polar plot end point will shift by minus 90 degrees. Okay, what will happen is the end point of the polar plot will shift by minus 90 degrees. If I'm able to add 0 to the system, then polar plot end will shift by plus 90 degrees. Okay, polar plot end will shift by plus 90 degrees. So simply by adding a pole or 0, we can make changes in the shape of the polar plot. So if I add pole to the existing system, the end of the polar plot will shift by minus 90. If I add 0 to the existing system, then end of the polar plot will shift by plus 90 degrees. Now let us see the sketches, typical sketches of the polar plot. Let us consider type 1 order 1, type 0 order 1 system. So you can see here the order of the system s power 1, highest power of s is 1 here. So order of the system is 1 and type is 0. Okay. So it is a type 0 order 1 system. So which g of s is given here. So you convert that into sinusoidal. Simply replace s by j omega. So if you replace s by j omega, 1 by 1 plus j omega t you will get. So now this is our sinusoidal transfer function. Okay, so for that determine the magnitude. What is the magnitude? Root of 1 square plus omega square t square. What is the angle tan inverse of omega t by 1? So this is it. Now this angle which is in the denominator, I have sent it to the numerator. So here, because of that, what will happen? The angle will become negative if it is sent from denominator to the numerator. So this is our sinusoidal transfer function. Now substitute omega equal to 0 in this. If you substitute omega equal to 0, 0 into anything 0, 1 plus 0 is 1, isn't it? 1 by root 1 is 1, 1 by 1 you will get magnitude. How much? What is the magnitude? Okay. What is the magnitude? Magnitude is 1 when omega equal to 0. And what about the angle tan inverse of 0 is 0. Now when omega tends to infinity, okay, when omega tends to infinity, when omega tends to infinity, substitute infinity here. So anything plus infinity, it will be infinity. 1 by infinity, you will get 0. Okay, magnitude is how much? Magnitude is 0. And what about the phase angle? Tan inverse of um, infinity is nothing but minus 90, because minus tan inverse of infinity is there. Okay, so when omega equal to 0, magnitude is 1. So when omega equal to 0, what is the magnitude? It is 1. Okay, and what is the angle? Angle is 0. Okay, angle is 0 degrees. Now what is the, at omega tends to, as omega tends to infinity, okay, what about the magnitude? Magnitude is 0. Okay, magnitude is 0. What about the angle? That is minus 90. So here this is the minus 90 axis. As I have already told you, The polar plot will end at the origin. So at the origin, the polar plot will end. Okay. So polar plot will start here. Polar plot will start here. Polar plot will end here. Okay. So this is the polar plot for a type 0 and order 1 system. Okay. So omega is varying from omega equal to 0 to omega equal to infinity. So this is one of the typical sketches. This is one of the typical sketches. Next, type 1 order 2 system. Type 1 order 2 system. So one second. Type 1 order 2 system. So g of s is equal to 1 by okay, g of s is equal to 1 by s into 1 plus st. So g of j omega is equal to 1 by j. So replace s by j omega, you will get 1 by j omega into 1 plus j omega t. Now for this, determine the magnitude. Magnitude of j omega is omega. Magnitude of 1 plus j omega t. 1 plus j omega t is what? Root of 1 square plus omega square t square. Angle of omega is 90. Angle of 1 plus j omega t. Angle of j omega t is tan inverse of omega t. Okay. So this is it. Send the angles to the numerator. 90 will become minus 90 and tan inverse of omega t will become minus tan inverse of omega t. So now this is our magnitude. This is our phase angle. Now substitute once again omega equal to 0. Substitute omega equal to 0 in the above equation. So what will happen to the magnitude if we substitute omega equal to 0? It is, you will get 1 by 0, that is nothing but magnitude becomes infinity. And what about the phase angle? Phase angle is tan inverse of 0. Tan inverse, you just substitute the 0 here. So tan phase angle will become 0 and okay. So minus 90 minus 0, you will get minus 90. That's it. Okay. And when you substitute omega equal to infinity, g of j omega magnitude you will get 0 and angle you will get minus 180 because tan inverse of infinity is minus 90, minus 90, minus 90, you will get minus 180 degrees. Okay. So now when omega equal to 0, so what is my angle now? Minus 90. So I must go to this minus 90 axis now. From where what is the magnitude? It is infinity. So from some infinite point, the plot will start. From some infinite point, plot will start. What is the magnitude at omega equal to infinity? The plot will end at minus 180 axis. This is minus 180 axis. And what is the magnitude here? It is 0. At the origin, plot will end. Okay. So this is the plot for type 1 order 2 system. Okay. So while listening, you people, if you want, you just note it down quickly. These are important. If any issue is there, please inform. Okay. So let us go to the next type and order as quickly as possible. Try to write so that it will be useful to you. Now, type 0 and order 2 system. Type 0 means here you can see s power 0. S is not there. So type 0. Order 2 means highest power of s is what? If you multiply all the terms, you will get s power 2. So it is order 2 type 0 system. So replace s by j omega. So if you replace s by j omega, you will get 1 by 1 plus j omega t1 into 1 plus j omega t2. Okay. So what about the magnitude? So what about the magnitude? Magnitude for this first term is what? It is root of 1 square plus omega square t1 square. Magnitude of this second term is root of 1 square plus omega square t2 square. Angle of first term is tan inverse of omega t1. Angle of second term is tan inverse of omega t2. Okay, divided by 1, even if you write 1 or even if you won't write 1, it doesn't matter. So write all the magnitudes on one side and all the angles which were in the denominator, we have sent it to the numerator. So minus tan inverse of omega t1 minus tan inverse of omega t2 you will get. Okay. So now for different omega values. Now for different omega values, so let us see what is g of j omega. So where is my cursor? It is here. So for omega equal to 0, g of j omega magnitude, you just substitute here 0, you will get magnitude 1 and angle you will get 0 degrees. And if you substitute omega infinity, then you will get magnitude 0 and angle minus 180 degrees. Okay. So now so what is our starting point? It is the angle, reference axis angle is 0 degrees and end point angle is minus 180. So this is minus 180. This is 0 degrees. What is the magnitude at 0 degrees where the plot will start? Okay. So magnitude is 1. So this is 1. And what is the magnitude where the plot will end? It will end at the origin magnitude is 0 here. So the plot will start from 1 and it will travel up, it will start from 0 degrees. It will end at minus 180 degrees, of course. But the value from which it will start is 1. Okay, the magnitude from which it will start is 1. So this is the plot, polar plot for type 0 and order 2 system. Okay, let us go to the next type. Okay. Okay. Type 0 order 3 system. So type 0 order 3. So you can see here it is type 0 system and highest power of s is 3. So this is type 0 order 3 system. So replace s by j omega. Replace s by j omega and there are three terms here. So you can write down root of 1 square plus omega square t1 square, one magnitude. Other magnitude is 1 plus okay. Okay, directly I have written here the magnitude and phase angles instead of replacing s by j omega. I didn't write that one equation here. I have skipped that equation. Okay, so that is root of 1 square plus omega square t2 square. Next, 1 root of 1 square plus omega square t3 square. Okay, and phase angle for each term is what? Tan inverse of omega t1, one angle, another angle is tan inverse omega t2, other angle is tan inverse of omega t3. So write down all magnitudes on one side and send all the phase angles which are in the denominator to the numerator. So here, as omega varies, when omega equal to 0, g of j omega magnitude is 1, and you just substitute omega 0 here in the above equation, you will get magnitude 1 and angle 0. And when omega is infinity, magnitude is 0 and angle is 270. So where is our 0 degrees? Here. And where is our minus 270? Here. So it is minus, negative means you must move in clockwise direction from 0 degrees. So what is the magnitude at 0? It is 1. So here magnitude is 1. From here it will start and it will end at origin of 270 degrees axis. Okay, type 0 order 3 system. Till now is it okay? Are you able to follow? If you have any doubt, you can mention in the chat box so that I will clarify the doubt. If anyone has any doubt, you can mention in the chat box. I will try to clarify. So next type is type 1 order 3. Next one, type 1 order 3. Let me check once. It has been a while. Yeah. Okay. So now let us see type 1 order 3 system. So you can see here s power 1. So type 1 order 3, you just multiply all the terms. So you will get highest power of s is 3. So order 3 system. So you just replace s by j omega, you will get this equation. Okay. Now write down the magnitudes. J omega magnitude is omega. Magnitude of 1 plus j omega t is 1 square plus omega square t square. And magnitude of 1 plus j omega t2 is 1 square plus omega square t2 square. Okay, and what about the phase angles of this first order denominator factors, isn't it? Angle is tan inverse of omega t1, another one is tan inverse of omega t2. These are the angles. Write down all magnitudes on one side and angles on the other side, and send them to the numerator. So if you send the angles to the numerator, 90 will become minus 90, tan inverse of omega t will become minus tan inverse of omega t, and tan inverse of omega t2 will become minus tan inverse of omega t2. Okay, so substitute omega equal to 0 and omega equal to infinity. So when you substitute omega equal to 0 in the above equation, you will get magnitude infinity and angle minus 90 degree, and if you substitute omega equal to infinity, you will get magnitude 0 and angle 270 degree. So this is it. Now, so I'm sorry, I forgot to discuss about the plot. Now what is it? So it is starting from minus 90 and ending at minus 270. So this is our minus 90, this is minus 270. Okay, so what about the magnitude at minus 90? It is infinity. So from some infinite point, plot will start. Okay, from some infinite point, plot will start. From here it will start and it will end at the origin on 270 degrees axis. So it will start from 90, it will travel like this, and it will end at, so my pen is not cooperating with me. So it will start from here and it will end at 270 degree axis. Okay, so this is it. This is the plot for type 1 order 3 system. Next, type 2 order 4 system. In type 2 order 4 system, you can see power of s is 2, so it is type 2. If you multiply all the terms here, highest power of s will be 4. So order 4 system. So just replace s by j omega. You will get this 1 divided by j omega square into 1 plus j omega t1 into 1 plus j omega t2. This is what you will get. I want to check. Okay then. Are you able to follow or not? Mention. Mention in the chat box. Are you able to follow or not? Are you able to follow? Okay then. So here type 2 order 4 system. Type 2 order 4 system. So this is it. S power 2 type 2 order 4 means you just multiply all the terms, you will get s power 4. So now replace s by j omega, g of j omega sinusoidal transfer function. You will get this 1 by j omega square into 1 plus j omega t 1 into 1 plus j omega t2. Okay, now uh, determine the magnitudes and phase angles. For j omega square, magnitude is omega square, angle is minus 180 degrees. For 1 plus j omega t1, magnitude is root of 1 square plus omega t1 square, angle is tan inverse of omega t1. And for 1 plus j omega t2, magnitude is root of 1 square plus omega square t2 square, and angle is tan inverse of omega t2. Okay, now write down all magnitudes on one side and phase angles on other side. So if you write all magnitudes and phase angles on other side, this is how you will get. Now substitute omega equal to 0 and omega equal to infinity and determine the magnitude and phase angle. So when you substitute omega equal to 0, magnitude is, you will get infinity and angle as minus 180 degree. And if you substitute omega equal to infinity, you will get magnitude 0 and phase angle as minus 360 degrees. Okay, so when omega equal to 0, magnitude was infinity, so and angle is minus 1. So plot will start from minus 180, it will end at minus 360. Minus 360 means reference axis. So the magnitude is infinity, so from infinite polar plot will start and it will end at the reference axis origin. Okay, this is it. Next, type 2 order 4 order 5 system. So type 2 order 5 system. So you can see here s power 2, so it is type 2. And order 5 means you just multiply all the s terms, you will get s power 5. So this is it. Replace s by j omega. So sinusoidal transfer function you will get 1 by j omega square into 1 plus j omega t1 into 1 plus j omega t2 into 1 plus j omega t3. So determine the magnitudes for each and every term and determine the phase angles for all the terms. Okay, so these are the magnitudes and phase angles. Write all the magnitude terms on one side and phase angle terms on the other side. Okay, write all magnitude terms on one side and phase angle terms on the other side, and substitute omega equal to 0 and omega equal to infinity in the above equation. Okay, substitute omega equal to 0 and omega equal to infinity in the above equation. So if you substitute omega equal to 0, you will get magnitude infinity. If you substitute omega equal to infinity, you will get magnitude as 0. Okay, and if you when you substitute omega equal to 0, phase angle you will get minus 180, and when you substitute omega equal to infinity, phase angle you will get 450, sorry. So you will get minus 450. Minus 450 is greater than 360, so subtract with 360, you will get minus 90 degrees. Okay, you will get minus 90 degrees. So now our magnitude is when omega equal to 0, magnitude is infinity, phase angle is minus 180. When omega equal to infinity, magnitude is 0 and phase angle is minus 90. Okay, so these are our magnitudes and phase angles. So our plot will start from minus 180 and it will end at minus 90 degree. So both are negative, so we must move in clockwise direction. So from minus 180 it should start, and from at minus 90 it should end. Okay, it should start from minus 180 and it should end at minus 90. So this is our plot. Okay, so magnitude is infinity. So from some infinite point plot will start and it will end at the origin of minus 90. Okay, now let us see few more sketches of polar plot. Type 1, order 1. So if see g of s is what? 1 by s. So it is, what is the order of the system? 1. Type also 1. Okay. Now what if g of j omega? Just replace s by j omega. You will get g of j omega equal to 1 by j omega. So what is the magnitude of j omega? It is omega and angle is 90 degree. So send a 90 degree to the numerator, it will become minus 90. So 1 by omega at an angle of minus 90. Okay. So this is our magnitude and phase angle. So this is our magnitude and phase angle. Omega is 1 by omega is our magnitude here, and minus 90 is our phase angle. So substitute omega equal to 0, omega equal to infinity. So if you substitute omega equal to 0 and omega equal to infinity, so what will happen? The magnitude will become, when omega equal to 0, magnitude becomes infinity, and angle, of course it is constant, isn't it? It is constant. There is no variable term here. It is simply minus 90. So when omega is infinity, magnitude is 0 and angle is minus 90. So minus 90 is constant. So see, for both omega for the omega equal to 0 as well as for omega equal to infinity, the angle is same, that is minus 90. Since the angle is same, okay, so the polar plot will start from minus 90. Okay, it will be on the axis, minus 90 degree axis, that's it. Okay, so it will start from the end of the minus 90 axis and it will end at the origin of minus 90 axis. That's it. Okay, so it will start from the end of the minus 90 axis and it will stop at the I'm sorry, yeah, it will stop at the origin of the minus 90 axis. So this is the plot for type 1 order 1 system. Now let us go for the next case. Yeah, so next are few more typical sketches. Few more typical sketches. So g of s is equal to 1 plus st by st. This is our g of s. Replace s by j omega. Okay, replace s by j omega. If you replace s by j omega, you will get 1 plus j omega t by j omega t. Just simplify it, you will get 1 by j omega t plus 1. So see here, till now we didn't get this, such a case. Plus 1 is there. Okay, plus 1 is there. So we didn't get such a case till now. So here 1 by j omega t is there. Determine the magnitude for that and phase angle for that. Okay, so here this bracket is not there. This is it. So now here we have a constant along with a another magnitude whose which will vary with respect to omega. Okay, there is a 1 here. Now substitute omega equal to 0. If you substitute omega equal to 0, g of j omega magnitude is infinity at an angle of minus 90 plus 1 as it is. Whatever 1 is there, you write it as it is. Now substitute omega equal to infinity. Uh, then substitute omega equal to infinity in your magnitude term, you will get 0, and angle you will get minus, of course minus 90, it is constant, so it will remain constant. See, the angle is same for omega equal to 0 and omega equal to infinity. Angle remains same. So angle is not varying, therefore the plus it is this whole magnitude and phase angle both are adding with 1, so both are ones here, so you just consider 1 here on reference axis, and see here this at 1 this plot. Okay, the plot will start from minus 90. Of course it will not lie at the minus 90. Why? Because the 1 is added here, plus 1 is added here, which is a real term, isn't it? 1 is a real term, so real values will always lie on the in the first quadrant, that we already know. Okay, on the reference axis. So this is 1. So so it's parallel to minus 90 because an angle is same. So parallel to minus 90, draw a straight line which will start from the end of the 90-degree axis and it will end at the origin. Of course it is not the origin value, but parallel to the origin of 90 and parallel to the end of the 90-degree axis. This is the one of the typical case. Now let us see one more case. G of s is equal to s. So replace s by j omega. G of j omega equal to j omega. So what is the magnitude omega and what is the phase angle? It is 90 degree for j omega. Okay. So now substitute omega equal to 0, omega equal to infinity in the above equation. The magnitude you will get 0 and phase angle you will get infinity and sorry, magnitude you will get 0 for omega equal to 0 and for omega equal to infinity magnitude again you will get infinity and phase angle is 90 degree for both the cases. Okay, so plus 90, isn't it? It is plus 90. Earlier if you remember in the previous one of the sketches it was minus 90. So the plot will start from the origin here, and this is a typical case, and it will end at the end of this is minus 270 is nothing but plus 90. Okay, so this is 90 degrees. Minus 270 means okay. This is what happens. Minus 270 is nothing but plus 90 degree. So this is the axis. So along plus 90 degree axis, it will start from here, it will end at the end of this axis. Okay, one more typical case. One more typical case, g of s is equal to 1 plus st. So g of s is equal to 1 plus st. So replace s by j omega. So 1 plus j omega t you will get. What is the magnitude? 1 plus omega t, and angle is 90 degree for this. So here also similar to your previous case. This is the arrow mark. So this is it. So simply replace s by j omega. You will get 1 plus j omega t, and j omega t magnitude is omega t and angle is 90 degrees. So one is constant. So you substitute omega equal to 0 and substitute omega equal to infinity. Okay, substitute omega equal to 0 and omega equal to infinity. You will get 1 plus 0 at an angle of plus 90, and you will get 1 plus infinity at an angle of plus 90. So here 1 is there, so consider real value 1 on the axis. So of course it is plus 1, it will lie on the reference axis, and it is plus 90, therefore the plot will start from 1 and it will travel parallel to what? Parallel to minus 270. Parallel to minus 270 axis is nothing but plus 90 degree axis. Okay, this is one of the typical sketches. Okay, so we can solve some numerical problems. If you have graph, please inform. If you have graph in your hand, inform so that I can solve a numerical problem now. Do you have graph? Yes or no? Okay then. So we'll solve a numerical problem. You people plot the graph. So it's let us see. So an open loop transfer function of unity feedback system is given. G of s is equal to 1 by s into 1 plus s into 1 plus 2s. So this is our open loop transfer function. Okay. You have to sketch the polar plot and determine the gain margin and phase margin. You have to sketch the polar plot and determine the gain margin and phase margin. So just note down the problem. Okay, so write down g of s is equal to 1 by s into 1 plus s into 1 plus 2s. Now replace s by j omega. Replace s by j omega, and if you replace s by j omega, g of j omega, you will get 1 by j omega into 1 plus j omega into 1 plus j 2 omega. Okay, 1 by j omega into 1 plus j omega into 1 plus j2 omega, 1 plus j2 omega. Now we have two factors here, isn't it? We have two factors. First order denominator factor. This is 1, this is 1. Two factors are there. Two first order denominator factors are there. So for these two first order denominator factors, we can determine the corner frequencies. So what is our corner frequency? Omega C1 equal to 1 by 2, one corner frequency. Another corner frequency is omega C2 is equal to 1 by 1. So we have got 0.5 radians per second one corner frequency, and another corner frequency is 1. Just note it down. If you complete inform, if you complete this slide, just inform so that I can change this slide. If you complete, please mention completed. Okay then. Now, what are sinusoidal transfer function that we have? Okay, what are sinusoidal transfer function that we have? So just write down the magnitude. J omega is nothing but magnitude of j omega is omega. Magnitude of 1 plus j omega is root of 1 square plus omega square, and magnitude of 1 plus j2 omega is what? 1 square root of 1 square plus 2 omega square. Okay, so what about the angle of omega? It is 90 degrees. So you send 90 degree to the numerator, it will become minus 90. Angle of 1 plus j omega is tan inverse of omega. Send it to the numerator, it will become minus tan inverse of omega. And angle of 1 square plus 2 omega square is minus tan inverse of 2 omega. Okay, so now determine the magnitude, and just did not determine, you just separate the magnitude and phase angle. So magnitude is what? 1 by omega root of 1 square plus omega square into 1 square plus 4 omega square, and angle is minus 90 minus tan inverse of omega minus tan inverse of 2 omega. So if you complete this slide, inform. Okay, then now let us assume different omega values. Okay, different omega values. So we have got some corner frequencies, isn't it? Our corner frequencies were zero point 0.5 and 1. Okay, so whatever omega values that we are going to consider, we must consider including the corner frequencies or nearby to the corner frequencies. Okay, the omega value should be around the corner frequencies. You can even consider the corner frequency values. So here, let us consider table 1. In this table 1, uh, the first column has omega, next next term is magnitude, next term is phase angle. Okay, so different omega values, you just assume different omega values. I have included the corner frequency values also. So different omega values you just consider. Okay, some randomly. There is no need to consider uniform values of omega. Means if I am assuming here as point 0.1, next point 0.2, point 0.3, point 0.4 and all uniformly, there is no need to assume the omega values. Your wish, any values nearby to your corner frequency and around your corner frequency you can consider. So I have considered some values here for omega. For each omega value, each omega, so first omega value is 0.35. Substitute 0.35 in this equation. Okay, and determine magnitude. Okay, also substitute 0.35 in this angular equation and determine the angle. Okay, so for each omega value, determine the magnitude and phase angle. So I have got all these magnitudes and phase angle. No need to calculate, just copy it down. No need to calculate, just copy it down. So after determining all the magnitudes and phase angles, okay, what we have to do is, where is my cursor? Yeah, it is here. What we have to do is, we have magnitude values for different omega values. Write down another table with the same omega values. Same omega values you have to write it down in the next table also. Okay, now you people have a magnitude and phase angle. So with the help of calculator, you have this magnitude and phase angle means you have a polar form. So in your calculator there will be an option to convert polar form to rectangular, rectangular to polar. So in your using calculator, simply directly substitute, just select rect REC on your calculator. So after selecting REC, just type 2.2 comma minus 144 and close the bracket and press enter whatever is there in your calculator. You will get the rectangular form values minus 1.78 and minus 1.29 for this magnitude and phase angle. Okay, similarly, so to get the magnitude and phase angle values from the sinusoidal transfer function magnitude and phase angle formula, you have to determine all these values in table 1. For table 2, directly substitute the, go for the conversion in your calculator, polar to rectangular conversion and substitute the magnitude and phase angle. You will get real part and imaginary part. So this is our real part, gr of j omega, gi of j omega is our imaginary part. Okay, so for each omega value, okay, so you need not bother about the omega here. Simply for each omega, for this 0.35 you have already determined the magnitude and phase angle. So you people determine the real part and imaginary part from the calculator directly. Okay, so this is it, this is how you have to do it. And write down all the real values and imaginary values from their corresponding magnitude and phase values. Okay, just write it down. As soon as you complete, inform. Did you complete? Take the screenshot at least of this slide. Even if you miss, you can write it down later. Okay, so this is it. Here I have considered 2 centimeter, not 2 centimeter equal to 1 unit. I have written here 1, but it is 2 centimeter equal to 1 unit. So depending on the real values and imaginary values, I have taken this scale, and make sure you take the uniform scale for real values and imaginary values. I have got real and imaginary all negative values. That's why our plot is in the third quadrant. I'm considering maybe I may get the plot in the third quadrant because all negative values are there. So definitely plot will lie in the third quadrant. Okay. So this is my real axis. This is my imaginary. Take a normal graph sheet and draw the scale. If you complete, just inform so that I can change the slide. Okay, I'm going to the next slide. Now you can see here one is there, here one is there. Okay, so you just take a compass and draw a circle from this one to this one. So you will get 1/4 circle in each quadrant, isn't it? If we have, so if you see here in this, where is it? Yeah. So this is a complete circle, isn't it? So each quadrant occupies 1/4 circle. Okay, each quadrant occupies 1/4 circle. So, so take a compass, you put it, keep your pin at the origin and just take the length up to 1. Okay, up to 1. From 1 to 1, join 1 to 1 with the compass. So This is our unity circle. This is known as unity circle. This is our unity circle. If you complete inform. Now from the table, this is our table, isn't it? So we have some real values. These are our real values. We have some imaginary values. Okay. Okay. So write down, just locate the real values and imaginary values on the graph. So these are the points. Okay. Locate these points on the graph from the table. Locate the points on the graph from the table. You will get this. Okay. So this is 2 centimeters. This is 2 centimeters, not 1. So this is what you will get. This is this is the graph that you will get. And look at write their corresponding omega values at each point. For which omega you got these points, you write down all those omega values at each point. If you complete inform. Okay. Now now what you do is take a scale, join the origin with the intersection point of this plot, polar plot, with the unity circle. Okay. Draw a dotted line. Draw a dotted line from the origin to the intersection point of the plot on the unity circle. Okay. So after drawing that, with the help of protractor from the reference axis in clockwise direction, sorry, okay, take a protractor from the reference axis in clockwise direction, measure the angle. Okay, measure the angle with the help of a protractor. With the help of a protractor, measure the angle. So this angle is nothing but gain crossover, phase at gain crossover. Okay. So phase at gain crossover frequency we can say. So phase at gain crossover frequency. That is the angle. at phase at gain crossover frequency. So with the help of protractor, if you measure, you will get minus 168 degrees. Okay, since we are doing manually, you may not get exactly minus 168, you may get minus 166 or minus 167 or minus 169 or maybe we minus 170. So parallax error may occur, it's okay, but approximately nearby to minus 168 you will get some value. So whatever angle that you get, that is our gain phase at gain crossover frequency. Okay, so this is it. Draw a, with the help of scale, join origin with the intersection point of this plot with the unity circle and measure the angle. So angle I have got minus 168. If you complete, inform. Okay, this is it. Now, if you see carefully, this plot, this polar plot that you have got, this blue color line that you have got, this polar plot, uh, from the origin, if you see carefully, from the origin, it is starting like this. I will take a pen. So, of course, it is not starting from the origin. It is traveling from here to it is ending at the origin. Okay, this is my plot. So, this is the direction, okay, of the plot. Okay. Uh, so, this is it. This is my plot. Now, this plot will is cutting the real axis, isn't it? This is our real axis. So this is our real axis. This is our real axis. So this plot cuts the real axis at this point. What is this point? What is this point? This point is what? It is in between minus 0.6 and minus 0.8. It is in between minus zero point 0.6 and minus 0.8. It is 0.7. Okay. So what is the length here? Length of um, the part on the real axis where this plot intersects is, what is that length? It is 0 minus 0.7 and magnitude is how much? 0.7. That magnitude you will call it as GB. Okay, what is GB? It is the length of the plot on the real axis where the, okay, so where the plot intersects the real axis. Okay, so that is our GB. So this is my GB. GB is from here to here. Okay, up to this point. This is GB. Now, let us see the gain margin and phase margin. So gain margin, sorry. So gain margin is equal to gain margin, its notation is k suffix g. It is equal to 1 by g of j omega pc. Pc means phase crossover. So sinusoidal transfer function at phase crossover. Okay. So 1 by sinusoidal transfer function as at phase crossover is nothing but our gain margin. So again, what is g of j omega pc? Its notation is GB. So just now we have calculated GB value from the graph, that is 0.7. Okay. from the graph it is 0.7. So 1 by 0.7 you will get 1.4286. So this 1.4286 is the gain margin. Next, phase margin. So phase margin formula is 180 plus 5GC. What is 5GC from the graph? It is minus 168. So 180 minus 168, it is 12 degrees. Okay. So they have asked us to determine the phase margin and gaze margin. So we have determined the phase margin and gain margin. This is it. Write it down. If you complete, please inform. Okay. Next problem. Note it down. Solve it. And if you get the answer, you just type in the comment box of my channel. So next problem is open loop transfer function of unity feedback system is given. G of s is equal to 1 by s square into 1 plus s into 1 plus 2s. Okay. You have to sketch the polar plot and you have to determine the gain margin and phase margin. So you solve it, you determine the gain and phase margin and you mention in the comment box so that I will tell you whether the answer is right or wrong. So same pattern whatever we have followed for the previous problem, same pattern has to be followed for this numerical problem also. So just write it down. So similar to previous problem, here also what you have to do is you take the open loop transfer function, just write it down, replace s by j omega. So this is it. G of j omega you will get. So 1 by j omega square into 1 plus j omega into 1 plus j 2 omega. You, you will get, you just determine the corner frequencies for these two uh, first order denominator factors. So you will get omega c1 equal to 1 by 2 equal to 0.5 radians per second, and omega c2 equal to 1 by 1, that is 1 radian per second. So determine similar to same pattern you have to follow, and this is how you will get the g of j omega. Okay, so you just determine the magnitude of each and every term and determine the phase angle of each and every term. After determining the magnitude and phase angle, what you have to do, you have to um, you have to write down the tables for different omega values. You people determine the magnitudes and phase angles, and once you have determined the magnitudes and phase angles using the calculator. You people just determine the real values by polar to rectangular conversion form. You determine the real values and imaginary values for each and every omega. Okay, so after determining real values and imaginary values for each and every omega, you take the normal graph sheet. Consider 1 centimeter equal to 0.2 here. Okay, so 1 centimeter equals actually it's not 0.2, it is I will write it down here so that a scale is a bit different. Here I have considered 2 units or 2 centimeters. Yeah, I have considered 2 centimeter equal to 0.4. Just so my scale I have written something else here. 2 centimeter is equal to 0.4. Okay, 2 centimeter, but I have written here 1 centimeter. Yeah, it's correct only. 1 centimeter equal to 0.2, so 2 centimeter is equal to 0.4. It's right. Okay, 2 centimeter equal to 0.4, so 1 centimeter equal to 0.2. So this is my scale. So you have to take uniform scale for both real axis and imaginary axis, and based on the values that you have got in the table, you can say that all the imaginary values are positive and all the real values are negative. So your plot you will get in the second quadrant. Okay, draw the unity circle wherever 1 is there. From 1 to 1, join the circle with the help of compass. The help of compass, draw the unity circle. Just the pin here, keep your pin here and pencil here, and just rotate from here to here. You just rotate your compass from one point to this point. This is it. Now after drawing unity circle, now locate all the points on the graph for each and every real and imaginary value. Locate the points on the graph. This is how you will get. Okay, this is how you will get. Now join all the points. This is our plot. This is our polar plot. So if you observe here, this polar plot is not intersecting the real axis. It is passing through the imaginary axis, but it's not intersecting the real axis. Therefore, we will assume that GB will be at some infinite point. It will intersect the imaginary axis at some infinite point. So GB is equal to infinity. So what you do is you take a scale. Uh, you take a scale, join the origin with the intersection point of unity circle with the plot. Take a scale and join the origin with the intersection point of unity circle with the plot. So this black dotted line you will get, and measure the angle from the reference axis in clockwise direction. It is approximately 270, isn't it? It is approximately 270. So 5 GC is, you are moving in a clockwise direction, so 5 GC is minus 270. Okay. So 5 GC is minus 270. So this orange color, if you observe here, you can find it. So this is our angle. So this is our graph. Now determine the gain margin. So what is gain margin? K suffix g is 1 by g of j omega pc. That is sinusoidal transfer function at phase crossover frequency. So that is nothing but GB. GB is what? We have assumed that it will intersect, the plot will intersect the real axis at some infinite points. Therefore, GB is infinity. So 1 by infinity is nothing but 0. So gain margin is 0. 5 GC we have got minus 270. So 180 minus 270, it is minus 90. Okay. So you people solve this and plot the graph.